Hi, I'm Brian Givens, creator of dbiScript. Welcome to the dbiScript Northwind tutorial. In this tutorial, we'll be using dbiScript to create a browser-based graphical user interface to the Northwind database. Before we begin, you'll want to switch YouTube to the maximum streaming resolution. First, click on the little gear icon towards the bottom right of the YouTube window. Next, select Original from the list of options. That's a resolution of 1920 by 1200. Finally, click on the full screen icon at the very bottom right hand corner of the YouTube window. We'll begin with a preview of the completed dbiScript application. The entire graphical user interface is generated on the fly by dbiScript based on the dbiScript application code. This is an amazing advance in technology. What would normally take a skilled developer months to accomplish can be achieved very quickly with dbiScript. In this tutorial, we'll be looking at the Northwind database. The Northwind database is a sample database which ships with Microsoft's Access and SQL Server products. The Northwind database is a simple order management system consisting of just 8 tables. In the completed Northwind dbiScript application, the initial page frame provides access to 5 of these tables: customers, employees, shippers, suppliers, and categories. The other 2 tables in the initial page frame, users and groups, are for administrative purposes and will be covered in detail in the security tutorial. The other tables of the Northwind application are products, orders, and order items. In the dbiScript interface, these tables are accessed by first selecting a row in a related table. When we select a row in the customers table, a second page frame appears. Now keep in mind these page frames are automatically handled by dbiScript. In this second page frame, you notice that in addition to employees, we now have orders, order items, and products, along with shippers, suppliers, and categories. The tables in the second page frame show only those rows related to the customer selected in the first page frame, in this case, Alfred's Food or Kist. In the Northwind database, the orders table contains foreign keys to both the customers and employees tables. dbiScript automatically uses this relational information to establish the tables of the second page frame. All the orders shown in the second page frame have been placed by Alfred's Food or Kist. The only employees shown in the second page frame are those employees who have placed an order for Alfred's Food or Kist. Similarly, the rows of each table in the second page frame are related to Alfred's Food or Kist through the orders table. Again, all this is handled automatically by dbiScript based on the dbiScript application code. The check mark in the first column of the employees row indicates that the employee has a related record in the orders table. Clicking on the toggle button in the header of the indicator row switches the display to all rows. In this case, we now see all employees. Clicking on the toggle button again reverts to the filtered display. When dbiScript has identified multiple relational filters for a table, right-clicking on the toggle button will enable the user to select a specific filter. You may notice that the toggle button has now reverted to the gray check mark of the initial view. The gray check mark indicates that a specific filter has been chosen from the list. When a page or tab of a page frame is first displayed, and dbiScript has identified multiple relational filters for that table, it will initially pick the filter it feels is most relevant, in this case rows with orders. Selecting an employee will now display a third page frame. The orders displayed in this page frame have been placed by Margaret Peacock for Alfred's Food or Kist. Again, all the rows displayed for each table in this third page frame are related through the orders table to Margaret Peacock and Alfred's Food or Kist. The one exception is this last tab, which has been added by dbiScript because of the Reports to reference field in the employees table. Going back to the orders table, if we now select an order, we'll see the order items attached to that order. The first field of the order items table is the product, for which we've used a reference field. One feature of the reference field I'd like to point out is this magnifying glass toggle. When clicked, it displays all the information about the product as well as any foreign information. In the Northwind database, the product table has foreign keys to both the supplier and category tables. In this case, the veggie spread product is supplied by Pavlova Limited and is in the condiment category. Again, all this relational information is handled automatically by dbiScript. Before we conclude this preview of the completed Northwind application, I'd like to demonstrate some of the functionality inherent to each data table. First of all, the active table in the interface appears in this reddish font with a dotted underline. Currently, order items is the active table. We'll click on customers to make the customer table the active table. Keystrokes are now directed to the customers table. Pressing the down key on the keyboard scrolls downward through the displayed rows. When we get to the last displayed row, pressing the down key again navigates to the next page of data. From this point, pressing the up key takes us back to the previous page. Pressing the up key again scrolls upward through the displayed rows. Pressing the page down key navigates to the next page of data, and pressing the page up key navigates to the previous page. Pages can also be navigated by clicking on any of the page indicators at the bottom of the page frame. To edit a row, click on any field in the selected row. This will also set focus to the field and select any text. We can now make changes to the row and then save our changes by either clicking the Save Changes icon or pressing Ctrl S. The HTML titles of the new, copy, and delete icons are customized for each table. So to add a customer, we click on the new customer icon, make some changes, and save the row. Then to delete the customer, we'll just click the Delete Selected Customer. To create a new customer, by first copying the details of a selected customer, we click on the Copy Selected Customer icon. The Cancel Changes icon simply cancels any changes that have been made to the row, and is identical to the Escape key on the keyboard. The sort order of the rows may be changed by clicking on any field heading. The first click of that field heading will sort the rows by that field in ascending order. Another click of the same field heading will sort the rows by that field in descending order. More complex sorts may be specified with the Sort Rows dialog box. The Search Rows dialog box is used to find rows matching specific criteria. The Search Rows dialog box is extremely powerful and there is a great deal to cover. We'll do so in a future video. The Quick Filter provides a simple interface to do a case-insensitive search for fields which begin with specified characters. As you've probably noticed, a row's fields are divided into inline and drill down sections. A row's drill down fields are normally only displayed when a row is selected or in edit mode. However, the Pin Row button can be used to pin a row in place so it can be visually compared with other rows. To clear the pinned rows, right-click and select Unpin All Rows. And finally, the Minimize icon can be used to minimize the table display to the selected row and free up more room on the page. This concludes our brief introduction to the dbiScript interface. There is a lot more to dbiScript, and we'll go into much greater detail in future videos, but now it's time to take a look at the code behind the interface. A dbiScript application can be managed with any text editor. My personal preference is TextPad. The dbiScript application consists of 3 files: the HTML index file, the database configuration file, and the dbiScript application file. Here we have the complete Northwind dbiScript application code. I'm going to get rid of most of this code and walk you through the process of creating the Northwind application. I'll start by showing you the process that I call creating the dbiScript application skeleton. That is, we'll add each table to the interface along with just one field per table. It's a quick way to see how the relationships you've established affect the dbiScript interface, and to ensure that your project's design criteria match your end user's expectations. I'll start with just the customers table and refresh the browser. You can see how that initial page frame has been reduced to just the customers table. Next, I'll add in employee, shipper, supplier, and category. At this point, there are no relations between any of the tables in the application. Selecting a row in any of the tables of the first page frame will not result in the display of a second page frame. Now we'll add in the product table. The product table is the first table in our application to have relationships to other tables in the application. In this case, product has foreign keys to both supplier and category. When we refresh the browser and go into the supplier table and select a row, we now get a second page frame. Now we'll add in the order and order items tables and refresh the browser. When we select the customer and employee, we now see the related orders and order items. We've completed the dbiScript application skeleton. I hope you can appreciate how incredibly quickly we've put this together. With any other tool, it would take a skilled developer months to accomplish what we've done in about 2 minutes. I hope you'll agree with me that this is awesome. Now I'll complete the application by fleshing out each of the tables. Here we've added all the fields to the customer table. I'll refresh the browser and there are the fields. You can see that the order of the fields in the interface is dependent upon the order they were added to the dbiScript application. And also, the fields in the drill down portion of the row were added with an append drill down data function as opposed to the append data function which adds them to the inline portion of the row. Now I'll flesh out the employees table and refresh the browser. What's new here is the reference field. The reference field links to a row in another table, or, as in this case, the same table, the employee to which the selected employee reports to. As I mentioned previously, clicking on the magnifying glass icon brings up all the information about the linked row. Another feature of the reference field is that in edit mode, the edit icon provides access to the reference table. Now I'll flesh out the shippers and suppliers tables. What's new in the suppliers table is the URL field. The URL field is a simple field which provides an HTML anchor to link to another website. I'll refresh the browser and show you how that field looks in the suppliers table. Here we're linking to the Wikipedia main English website. Now we'll edit the field to point to a different page on Wikipedia. There are 26 different field objects in dbiScript. The purpose of this tutorial is to provide a quick introduction to the relational features of the dbiScript programming language. We'll dig much deeper into the dbiScript field objects in the next video in the series. I'll quickly flesh out the next 3 tables in the application. There's categories, products, and orders. What's new in the orders table is the grouped drill down fields. This groups together a list of drill down fields, in this case ship address, ship city, ship region, ship postal code, and ship country. I'll first show you an order row without grouping. And now I'll go in and add the grouping. Now I'll flesh out the order items table. What's new here is the percentage field, which simply stores a number as a decimal and displays it as a percentage. Here's the percentage field in edit mode. Initially, the field as we defined it in the Northwind application is not very useful for a discount field because huge values and even negative numbers can be entered. We'll add optional parameters to the field to get the behavior we'd expect from a discount field. All 3 parameters here refer to the stored values of the field. We'll give ourselves 2 decimals so that 25% will be stored as 0.25. The maximum value of 0.5 is equivalent to 50%, and our minimum value is 0. Now we'll refresh the browser and go back to that same row. When we edit and then attempt to save the row, we now get a validation error. We'll try 100% and we get the maximum validation error. We'll go back to 25% and we have no problem. The dbiScript data-driven functions are used to further refine a field's behavior. I've just added a verify data-driven function to the order item discount. The data-driven functions must be named following the precise naming convention table name underscore field name underscore data-driven function name. The verify data-driven function is passed the current value of the field. If a string is returned from the function, then the user must verify their changes before the row can be saved. In this case, if the discount is greater than 25%, then the user must confirm the discount. We'll save our changes, refresh the browser, and test out our function. There are many data-driven functions in dbiScript, and they're all well documented in the dbiScript Programmer's Reference Guide. I'll demonstrate the update value data-driven function with the order items product, unit price, and discount. The update value data-driven function is passed 7 parameters: the table name of the field being updated, the field name of the field being updated, the current value of the field of the data-driven function, the previous value of the field being updated, the current value of the field being updated, an object containing the current value of every field of the table of the data-driven function's field, and an object containing every related field value sorted by table name. The update value data-driven function, which I've written here, will update the value of the order item's unit price whenever the function's parameters match certain criteria. In the first line of our function, we look to see if the field being updated is the order item product ID. If it is, then we retrieve the unit price from the product of that last parameter and subtract the discount retrieved from that second last parameter, and we return the value rounded to the nearest penny. In the second line of our function, we look to see if the field being updated is the order item discount. If it is, then we do a bit of math to return the proper unit price. And finally, in the last line of our function, we return null to indicate that no changes should be made if we've reached this point. Now we'll update the browser and test out the data-driven function. I'll create a new order item and select a product. The unit price has been updated to reflect the price of that product in the product table. If I change the product, the unit price is updated again. I'll enter a discount, and the unit price is updated accordingly. I'll update the discount, and the unit price is updated again. That was just a demonstration of the use of the update value data-driven function. In a production order management application, we'd probably want to include extended price as a 5th column in the order items table. The dbiScript calculate field object would be used for the extended price, and the discount would be applied to the extended price instead of the unit price. Also, we'd want to add fields for order subtotal and order total to the orders table. For the order subtotal field, we'd use a dbiScript aggregate field object, which would calculate and display the sum of the extended price of all the items in the order. And finally, for the order total field, we'd use another dbiScript calculate field object, which would add the shipping cost to the order subtotal. This concludes the dbiScript Northwind tutorial. Thank you so much for watching. I hope you've enjoyed this introduction to the dbiScript programming language, and I hope you join me for the next tutorial on medical practice management. In the dbiScript medical practice management tutorial, we'll delve much deeper into the dbiScript programming language, and I'll touch on each of the 26 different dbiScript field objects. Until then, I'm Brian Givens, signing out.